Hi and welcome to the video training of Elixir. In this video training we will be learning about I/O and the file system. This video is a quick introduction to input-output mechanisms and file system related tasks, as well as to related modules like I/O, file and path. The I/O system provides a great opportunity to shed some light on some philosophies and curiosities of Elixir and the VM. First, let's look at the I/O module. The I/O module is the main mechanism in Elixir for reading and writing to standard input-output, standard error, files and other I/O devices. Usage of the module is pretty straightforward. So let's try this. Let's go and enter into Elixir interactive mode and try IO.puts. And I'm going to say hello world, and there we got hello world as an output. The next is how to get an input from the user. For that we use io.gets yes or no, and we got a question from the system saying yes or no. We say no. By default, functions in the I/O module read from the standard input and write to the standard output. We can change that by passing, for example, stderr as an argument in order to write to the standard error device. So I can say std error, comma, hello world, and I got an error saying undefined function std error. Okay, we forgot to enter colon and we got hello world. The file module. The file module contains functions that allow us to open files as I/O devices. By default, files are opened in binary mode, which requires developers to use the specific io.binread and binwrite functions from the I/O module. So for example, if we want to open file module, we need to use equal file.open hello and write no match on of right hand side value, error is comma file equals file.open hello comma write Okay, let's create a file called hello in the directory, and now get back to our interactive mode and try the same syntax we did before. File.open hello write. Okay, we still got an error, strange. Okay, file okay, io dot bin write file comma world undefined function file. Okay, now we can write io dot bin write and file world. This will write world into the hello file, and now we can close the file and now read the file called hello to see the contents of the hello file, and it says world. That's what we wrote in the file. A file can be opened with UTF encoding, which tells the file module to interpret the bytes read from the file as UTF-8 encoded bytes. Besides functions for opening, reading and writing files, the file module has many functions to work with the file system. Those functions are named after their Unix equivalents. For example, file.rm can be used to remove files, file.mkdir to create directories, file.mkdir under p to create directories and all their parent chain. There are even file.cpr and file.rmrf to respectively copy and remove files and directories recursively. That is, copying and removing the contents of the directories too. You will also notice that functions in the file module have two variants, one regular variant and another variant with a trailing bang. For example, when we read the hello file in the example above, we use file.read. Alternatively, we can use file.read ! So we use this. We could have used this as well, which only returns the string, the contents from the hello file. Similarly, we can say unknown got an error, and we can also use file.read ! And it says could not read file unknown, no such file or directory. Notice that the version with explanation returns the contents of the file instead of a tuple, and if anything goes wrong, the function raises an error. The version without explanation is preferred when you want to handle different outcomes using pattern matching. So if you want to do file do, and here we can say okay body and here we can say error reason handle the error caused by reason. handle the error caused by the reason, and in the case we got an error, syntax error before reason. Okay. However, if you expect the file to be there, the bang variation is more useful as it raises meaningful error message. Avoid writing okay body equals file dot read file. This raises an error of character data to string. As in case of error, file.read will return error reason and the pattern matching will fail. You will still get the desired result, a raised error, but the message will be about the pattern, which doesn't matter, thus being cryptic in respect to what the error actually is about. Therefore, if you don't want to handle the error outcomes, prefer using file.read explanation mark. Let's now look at the path module. The majority of the functions in the file module expect paths as arguments. Most commonly, those paths will be regular binaries. The path module provides facilities for working with such paths. So, if you want to join two paths, foo bar get foo / bar, and if you want to expand hello get the directory name hello Osman hello. Using functions from the path module as opposed to directly manipulating string is preferred, since the path module takes care of different operating systems transparently. Finally, keep in mind that Elixir will automatically convert slashes into backslashes on Windows when performing file operations. With this, we have covered the main modules that Elixir provides for dealing with I/O and interacting with the file system. In the next sections, we will discuss some advanced topics regarding I/O. Those sections are not necessary in order to write Elixir code, so feel free to skip them, but they do provide a nice overview of how the I/O system is implemented in the VM and other curiosities. Processes. You may have noticed that file.open returns a tuple like OK PID. That happens because the I/O module actually works with processes. Given a file is a process, when you write to a file that has been closed, you are actually sending a message to a process which has been terminated. So if you write io.write file, is anybody out there, it will return error with terminated signal. Let's see in more detail what happens when you request io.write PID binary. The IO module sends a message to the process identified by PID with the desired operation. A small ad hoc process can help us see it. So PID equals spawn function receive do message io.inspect message end. And when you run io.write PID hello, you're writing to the process ID with the process, sending a string. After io.write, we can see the request sent by the IO module, a 4-element tuple printed out. Soon after that, we see that it fails since the IO module expected some kind of result which we did not supply. By modeling IO devices with processes, the Erlang VM allows IO messages to be routed between different nodes, running distributed Erlang or even exchange files to perform read-write operations across nodes. Let's look at IO data and character data. The functions in IO and file also allow lists to be given as arguments. Not only that, they also allow a mixed list of lists, integers and binaries to be given. So if we use io.puts hello world, we get hello world, and if we use io.puts and we pass in the list hello question mark \s and then world, we get hello world that is the same result. However, using lists in IO operations requires some attention. A list may represent either a bunch of bytes or a bunch of characters, and which one of use depends on the encoding of the IO device. If the file is opened without encoding, the file is expected to be in raw mode, and the functions in the IO module starting with the bin static must be used. Those functions expect an IO data as an argument. That is, they expect a list of integers representing bytes or binaries to be given. On the other hand, stdio and files opened with UTF encoding work with the remaining functions in the IO module. Those functions expect a character data as an argument, that is a list of characters or strings. Although this is subtle difference, you only need to worry about these details if you intend to pass lists to those functions. Binaries are already represented by the underlying bytes, and as such their representation is always raw. This finishes our tour of IO devices and IO related functionality. We have learned about 3 Elixir modules, IO, file and path, as well as how the VM uses processes for the underlying IO mechanisms and how to use character data and IO data for IO operations. If you liked this video, don't forget to subscribe to my channel. If you need any professional help, you can email me umahmood@gmail.com. You can visit my Facebook page or my LinkedIn profile, and I'll always be more than happy to help you. See you next time with a new topic in Elixir.